Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is measures of dispersion-quartile deviation. In our previous video, we started with range. Range is the interval or the distance on the scale of measurement, which includes 100% cases. The limitations of the range are due to its dependence on two extreme values, highest and lowest score only. There are some measures of dispersion which are independent of these two extreme values, highest score and the lowest score. Most common of these is the quartile range, which is based upon the interval containing the middle 50% of the percent of cases in a given distribution. Quartile deviation is actually 1/2 the scale distance between the third quartile and the first quartile. It is nothing but the semi-interquartile range of the distribution. So before taking up the quartile deviation, we must know the meaning of quarters and quartiles. In range, we consider the highest score and also the lowest score. So these are the information we have to look in between the highest score and the lowest score. I'm going to divide this into 3. Q1 is the 25% is the Q1, which is the other name for first quartile. And Q2 is the 50%, which is the second quartile. And 75% is the third quartile, and the leftover is highest score. Okay, so these are the quarters and quartiles. Hope you're clear with this figure. For example, a test results 20 scores, and these scores are arranged in a descending order. So let us divide the distribution of scores into 4 equal parts. Each part will present a quarter. Quarter means 25%. In each quarter, there will be 25% cases, or 1/4 of n, 1/4 of total. As scores are arranged in descending order, the top 5 scores will be in the first order. 20, if you are dividing 20 into 4, 5. The top 5 will be in the first quarter, next 5 will be in the second quarter, next 5 will be in the third quarter, and the lowest 5 scores will be in the fourth quarter. With a view to having a better study of composition of a series, it may be necessary to divide it into 3, 4, 6, 7, 8, 9, 10 or 100 parts. Usually, a series is divided in 4, 10 or 100 parts. One item divides the series into 2 parts, 3 items in 4 parts, 9 items in 10 parts. 4 parts means quartiles, 10 parts means deciles, D-E-C-I-L-E-S. And 99 items in 100 parts are called percentiles. There are thus 3 quartiles, 9 deciles, 99 percentiles in a series. So you should be familiar with these terminologies. The second quartile or the 5th decile, or it can also be represented as 50th percentile. All these 3 denotes the same thing. So if the question denotes any of these terms, you should understand they all denote the same thing. The value of the items which divides the first half of series with values less than the value of the median. Median means the middlemost, Q2. Into 2 equal parts is called first quartile, Q1, or the lower quartile. Q1 is the lower quartile. In other words, Q1 is a point below which 25% of the cases lie. Q1 is the 25th percentile. And the second quartile is the median or the middle quartile. In other words, it is a point below which 50% of the scores lie. A median is the 50th percentile. The value of the item which divides the latter half of the series with values more than the value of the median into 2 equal parts is called third quartile, Q3. Or this is also denoted as upper quartile. In other words, Q3 is a point below which 75% of the scores lie. Q3 is also denoted as 75th percentile. 25th percentile, 50th percentile, 75th percentile. So a student must be clearly distinguished between a quarter and a quartile. Quarter is a range, but quartile is a point on the scale. Quarters are the numbers from top to bottom, or you can also say from highest score to lowest score. But quartiles are the numbered from the bottom to the top. So this is all about the quarters and quartiles. Now let us discuss the formula to find the quartile deviation. We generally denote quartile deviation by Q. Quartile deviation Q is 1/2 the scale distance between the third quartile and the first quartile. Third quartile is nothing but L plus 3n over 4 minus F divided by FQ times I. Let me explain what all these variables denote. L is nothing but lower limit of the class interval where Q3 lies. And 3n over 4 is nothing but 3 over 4 is nothing but the 75th percentage of the total data. 3/4 is nothing but 75%. Am I right? And F, capital F denotes the total of all the frequencies below L. And FQ is nothing but frequency of the class interval upon which Q3 lies. And the small I denotes the size or the length of the class interval. Hope you're clear with the quartile deviation formula. Okay. Now let us see interquartile range. We will also be seeing semi-interquartile range. Interquartile range is the range between the third quartile and the first quartile. Symbolically, interquartile range is Q3 minus Q1. Q3 means third quartile. Q1 is first quartile. Now let us see the formula for semi-interquartile range. The name itself explains what it is. Semi-interquartile range. Half of interquartile range, Q3 minus Q1. It is the half the distance between the third quartile and the first quartile. Q, the quartile deviation, is otherwise known as semi-interquartile range. Thus, Q is equal to Q3 minus Q1 over 2. If we compare the formula of Q3 and Q1 with the formula of median, we can observe few things. It will be clear that in case of median, we use n over 2. Hope you're familiar with the median formula for Q1 and n over 4 for Q3. We use 3n over 4 in the formula of Q3. In case of median, we use Fm to denote the frequency of class interval upon which median lies. But in case of Q1 and Q3, we use Fq to denote the frequency of the class interval upon which Q1 and Q3 lies. Hope you are clear with these formulas. Now let us discuss computation of the quartile deviation. Same as range, we are going to see examples for ungrouped data as well as grouped data. In order to calculate the quartile deviation, we are required to calculate Q3 and Q1 first because these are the things we need to put into the formula. Q1 and Q3 are calculated in the same manner as we were computing the median. The only differences are in case of median, we were counting 50% of the cases because n over 2 from the bottom. But in case of Q1, we have to count 25% of the cases. 25 means n over 4 from the bottom. In case of Q3, we have to count 75% of cases. That is 3/4 n from the bottom. Okay, let us start with the example. Here is an example. Find out Q of the following scores starting from 20 to 39. First, we have to count how many number of information is given, the total number of data. So here 5, 5, 5, 5. So totally there are 20 scores. So what would be the 25% of n? 25 means 1/4. Q1 is a point below which 25% of the cases lie. Hope you remember the figure I have mentioned from highest score to lowest score. So in this example, Q1 is a point below which 5 cases lie. From the mere inspection of the ordered data, it is found that below, what is the fifth one? 24.5. There are 5 cases. This number of information is arranged in ascending order. That's why I can directly say that 5 means it is nothing but here. So thus Q1 would be 24.5. Likewise, Q3 is a point below which 75% of the cases lie. So what is the 75%? 3/4 of n. So 3/4 of 20 is 15. So we find that 15th information is this thing. Value in between these two. So 34.5. 15 cases lie. So thus Q3 is 34.5 and Q1 is 24.5. So when you get ungrouped data like this, arrange them in the ascending order or descending order. I always suggest to arrange them in ascending order. After that, find Q1 and Q3. Here Q1 is first 5. So this would be 24.5. We always have to make it approximate, a number in between, so that it would be continuous and very closer to the accurate answer. And Q3 is 5 before, so 75%, so 34.5. After finding Q1 and Q3, just use the quartile deviation formula, Q3 minus Q1 over 2. Let's do the calculation now. We have found to first find what is Q1, first fifth, and Q3, third fifth. So below 5 cases, 24.5. Below 15 cases, 34.5. Now let's apply the formula for quartile deviation Q. Just plug in Q3 and Q1 that you got in this formula. Difference between 34.5 and 24.5 is 10. 10 over 2 is 5. Hope you're clear with this example? Okay. We can continue the same topic in our next video too. So when you're going to learn about the quartile deviation, you should know about the quarters and quartiles. Q1, Q2, Q3 and the other names that also denote Q1, Q2, Q3. Also you should know the formula to find the quartile deviation. And here is an example for ungrouped data. We can continue our next video with an example for grouped data. Also we can discuss the limitations and advantages of quartile deviation. In case if you have any query regarding this video, kindly let me know. See you in the next video. Have a